Good afternoon, friends. This is a series of lecture for TYBSC Analytical Chemistry student. But this lecture is different. In this lecture, we are going to learn about the practical involved in physical chemistry. Now here, physical chemistry practical, we are going to see. The title of the practical is to verify the Lamberts-Beer's law. And it is for the KMnO4 or potassium dichromate. Now we see for the potassium permanganate. Now, what is the statement of Lamberts-Beer's law? Lamberts-Beer's law is nothing but the concentration of the material is directly proportional, or consider concentration of the solution is directly proportional to absorbance of the solution when path length remains constant. Now here, this is the Lamberts-Beer's law, and we have to verify the Lamberts law accordingly for the solution. Now, what is the one limitation of Lamberts-Beer's law? You have to keep remind that it is applicable. The Lamberts-Beer's law is applicable for the for dilute solutions only. So at high concentrated solutions, Lambert-Beer's law fails. So this is the limitation of Lambert-Beer's law. Now here in this practical, accordingly aim of the practical, verification of Lambert-Beer's law with the help of colorimeter. Now the chemicals involved is that we have to perform in that chemicals, we have to prepare 0.001 molar KMnO4 solution, and we have to take the different concentration of KMnO4 solution itself. And another one instrument involved is colorimeter. Now these are the chemicals and apparatus of the practical. Now procedure. In the procedure, we just prepare a volume of K2Cr2O7, or you can say KMnO4, and volume of water, and we measure the absorbance. Firstly, take 0.01 molar KMnO4 in a cuvette or cell, and we have to measure the absorbance of the KMnO4 solution of 0.01 molar solution. Now accordingly, we have to take the we have to select the maximum lambda max value for the KMnO4 solution. So for that procedure, we take the solution in cuvette and measure the absorbance with reading 450, 470, 510, 520, 540, 570, 600 and 670 nanometer. Here we have performed the practical, and at that time we get the lambda max value, that is at 470 nanometer, and at that lambda max value the absorbance is nothing but the 1.24. Now what is the lambda max? Lambda max is nothing but the solution where we get the maximum absorbance at high concentration. So that is nothing but the lambda max value. So lambda max value is equal to 470 nanometer. Now we have to set this lambda max value, and accordingly we what was the solutions we prepare solutions with the help of this observation table. Now we take this we take the 6 cuvette, or you can say 6 test tube. In that 6 test tube, we number them 1 to 6. When we number them, in the first test tube, we take 10 ml of water, and 10 ml with the help of this 10 ml of water, we take the absorbance, and that absorbance is 0. In the second test tube, we take the volume of KMnO4 or K2Cr2O7 is 2, and in the similar test tube, we add 8 ml of water. In the third test tube, we measure the 4 ml of KMnO4 or K2Cr2O7 solution of 0.001 molar solution, and in the similar test tube, we add 6 ml of water. In the next test tube, that is the fourth test tube, we add 6 ml of K2Cr2O7 solution, and to this solution we add 4 ml of water. In the next test tube, we add 8 ml of K2Cr2O7, and we add 2 ml of water into it. In the last one, we take 10 ml of K2Cr2O7, and there is no need of water to add. And at that time, we just prepare a absorbance table, and we decant the solution and we take the cuvette, we take the measurable amount in the cuvette. So in the first test tube, we take some amount in the cuvette from that test tube and measure the absorbance. We get the 0 value, because in the first test tube there is a no concentration of K2Cr207 or can say KMnO4 solution, only water is there, so we get the 0 absorbance. And in the next test tube, we add 2 ml of water, we add 2 ml of K2Cr207 solution and 8 ml of water, then we get the value 0.26. For the third test tube, we get the absorbance 0.54. In the fourth test tube, we get the absorbance 0.72. In the fifth test tube, we get the absorbance value 0.96. And in the last one, as there is only K2Cr207 or KMnO4 is present and no amount of water is present, we get the 1.24 absorbance value. So this is all about the readings involved in the verification of Lamberts-Beer's law observation table. Now here we have plotted a graph of absorbance versus ml of KMnO4 added. Now when at the x-axis 2, 4, 6, 8 and 10 ml of KMnO4 or can say K2Cr207 and at the y-axis the absorbance is 0.2, 0.4, 0.6, 0.8, 1 and 1.2. So here absorbance value is there on the y-axis. On the x-axis there is ml of KMnO4 added, and we locate the points accordingly. What are the observation table, what are the readings involved in the observation table. So these are the, you can say, this is the first point, location of first point, this is the location of second point, this is the location of third point, this is the location of fourth point, and this is the location of fifth point, or you can say readings involved in. Here 0 is there, 0 absorbance. First reading is 0 absorbance of water. This is the first value, and this is second one, third one, fourth one, fifth one, and sixth one. Accordingly, this is the first for the 2 ml, this is the 4 ml, this is the 6 ml, this is the 8 ml, and this is the 10 ml of KMnO4 or can say K2Cr207 of concentration, having concentration 0.001 molar. So we just draw a line from the origin and we get this value, or can say we get the straight line passing through the origin, having its equation y is equal to mx, and these points are very near, or you can say near vicinity, near the line here, which we have already plotted through the origin. So here, according to Lamberts law, absorbance is directly proportional to concentration. So we see that this absorbance is directly proportional to, you can say, concentration. You can say these are the concentration of, you can say, different concentration of KMnO4, and these are the absorbance value, and we get this straight line from this. We can say accordingly the here, whatever the line, nature of the line, that is nothing but the absorbance is directly proportional to concentration, and that is a statement of Lamberts-Beer's law. And you can say from this experiment it is can say convenient to say that, or can say it is concluded that absorbance is directly proportional to concentration accordingly Lamberts-Beer's law. This is a statement of Lamberts-Beer's law, general statement. And here path length remains constant, or you can say path length is exactly equal to 1, because cuvette has a diameter centimeter by diameter in centimeter. So the cuvette has a diameter 1 centimeter, or you can say 1 centimeter cube. So naturally absorbance is directly proportional to concentration. So with this content I conclude this lecture. Thank you very much for your patience listening.